Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving two interesting problem on 2D array. So let's start. Let's look at our first problem. This is called transpose of a matrix. We have to find transpose of a matrix. So what is basically transpose? Transpose means row becomes column and column becomes zero. So here you have seen a matrix given. So these are 1 2 3. So what will be the first row? This will be the first row. So this is basically the first row, and this is second row, and this is third row. Now if we want to find the matrix transpose of this matrix, how it will be look like? So if we consider this row, this zeroth row, so it will be like first column. So this row will be replaced by column. So it will be like 1 2 and 3. Then second row, what will be the second row? 4 5 6. Then second row will be second column, 4 5 6, right? Then third row, it will become third column, 7 8 9. So this is called transpose of a matrix. Now how to solve this problem? So there are many approaches to solve this. So the first approach could be like you can take another space, another matrix, and you can run a loop from this, from row, and you can store the item in column wise. So you can iterate from rows, then you can store in column. So that you can do. But here the problem is that the we are basically taking a space. We are basically creating a new whole array and fill with 0 initially. Then we are just replacing the values. Means we are taking the space. But we don't want to take a space. We want to modify this matrix itself, right? Then how we can do that? Let's see how we can do that. Now let's look at this matrix. So this is the similar matrix 1 2 3 4 5 6 7 8 9. Okay, now this is called diagonal of the matrix, principal diagonal containing 1 5 and 9. Okay, now observe carefully. Observe carefully. When we transpose this matrix, when you transpose this matrix, this diagonal elements remain unchanged. This 159 remains unchanged. Only this elements, this 478 and this 236, these are changed, but the diagonal elements remain constant. Now when you look at in more details, you'll find that the upper triangular elements, this 236, are moved to lower triangular matrices. If you observe, this 236 is moved to this lower triangular elements 236, and this 478 is moved to upper triangular matrix elements 478. Let's try to understand how we can do that. First, let's assume this is our array, and what we have to do, we have to swap this 2 with 4. Then this 4 will be moved to this position, and this 2 will be moved to this position. So 4 will be here and 2 will be here. Then similarly, we have to swap the value between 2 and 7, 3 and 7. Then 7 will be moved to here and 3 will be here. And similarly with 6 and 8. And the diagonal elements will remain constant. Now let's see how we can programmatically do this thing. Now first, let's look at these two elements, 2 and 4. What are the indexes? What are the column index and row index for 2, and what are the column index and row index for 4? So the position of this element is 0 1, and position of this element is 1 0. You can see, so this j becomes I and I becomes j here. Similarly for 3 and 7, observe, this 0 becomes here, the row becomes column and column becomes 0. Means I becomes j and j becomes I, right? Similarly for this element also, 1 becomes 2, 2 becomes 1. And if you consider the diagonal elements also, you can observe the same thing. So 0 0, so those are basically same. If I equals to 0, j equals to 0, then if you swap them, so that will be same, right? So I becomes 0 here, j becomes 0 here, we can say that. Now let's see how we can do that. Let's assume first I have run a for loop. I have first go to this row 0, I have go to this row 0. Then I want to swap the elements. Let's say ARR of I with ARR of ij with ARR of ji. That I have to do. That I have to do. Okay. Now let's see. I am at 0 0 position. Now what will be the operation? ARR of 0 0 will be ARR of 0 0, because I and j value are same. What I mean to say, if we first for the first row at 0 row 0, so if we run a for loop and first let's assume this element, so it will be like 0 0. Okay, I 0 j 0. And if we swap this element with the reverse thing, so this, so reverse of this will be also 0 0. Now let's say I want to control Z. Let's say I want to swap this value 0 0 with 0 0. So this doesn't make sense because this is single element. Now let's look at the second element in this row. Now when we are at this position, so what is the I value? I value is 0, I value is 0, and j value is 1. Now we have to swap this element with the element that has I equals to j, means I will be 1, j will be 0. What is the element at that position? It is nothing but 4. That means we have to swap this value with this. Okay. Now this 2 becomes 4 and 4 becomes 2. Now we'll be moved to the next column. Then what is the index of this? It is 0 2. Then we'll be swap this element with 2 0, because row becomes column and column becomes row. Now this 3, this 0 2 will be swapped with this 2 0. So let's swap it out. So it will be 3, it will be 7. Okay. So this row is done. This is done. Okay. Then what is next? That will be row 1. Okay. Fine. Now let's say we are at row 1. Now we'll be swapping this 1 0 value. Why we'll be swapping this value 1 0 with 0 1, right? Now let's see what is. Now this 1 0 will be swapped with 0 1. Now you can see there is a problem here. What is the problem? We have swapped twice here. So first we have swapped this 0 1 with 1 0. Then again we are swapping this 1 0 value with 0 1. Means we are swapping this value twice. That's why we'll not get the this required result. Right? Okay, let me first iterate over this. So let's say we are at, now this is done, we are at this position in the row 1. Now we'll be swapping this value with itself 1 1 with 1 1. Okay, then we'll be moved to this one. Now this 1 2 will be swapped by 2 1. Okay, now 6 become 8, 8 become 6. Now this row also done, this row 1 is also done. Okay, then we'll be moved to row 2. Okay, then it is 2 0. Then we'll be swapping this 2 0 with, we'll be swapping this 2 0 with 0 2 0 2. Means again we are swapping these two values. Again we are swapping these two values. Then we'll be moved to this. We'll be moved to this 2 1, and this is 1 2. Now again we'll be swapping this two value, right? Then we'll be at this position. Then we'll be swapping this 2 2 with 2 2. I, because I and j are same. Now tell me what are the mistake we are doing here. The only mistake we are doing here is we are swapping each value twice. Like first we have swapped this 2 with 4. Then again when we are at row 1, again we are swapping these two values. That's why we are not getting the deserving result, right? Now how to avoid this swapping by twice? We want to only swap by once. Now how we can avoid this? Now let's say we want to change this logic little bit. When we are at row 0, when we are at row 0, when we are at row 0, we'll be iterating from, we'll be iterating. So let's say we are at I equals to 0. Okay. Then what will be the j value? J will be running from I plus 1 to n minus 1. Let's say what I mean to say. So when we are at 0, j will be from 0 plus 1, 1 to 2. Okay. Then, so we'll be considering this value and this value for row 0. Now, when we are at I equals to 1, then j equals to 1 plus 1 equals to 2 to 2. So when we are at this row, when we are at this row, we will be performing only with this element, because here the j is 2. Here the j is 2, right? Okay. Now when we are at I equals to 2, now the j will be from 2 plus 1 equals to 3 to 2. Means when we are at row number 2, so we have to perform from index number 3, j equals to 3. But here the maximum index is 2. That's why we'll be not doing any operations. So in this process, how many operations we are doing? We are only doing 3 times. One for this element, one for this element, one for this element. Means we are just performing this operation for this upper triangular matrices. Why we are doing that? Because if we iterate over the whole matrix, then each element will be swapped twice. Then we'll get the same initial matrix as we have considered. That's why we have to only swap this once. And for this, first we'll be taking a loop for, it will be from I equals to 0 to n minus 1. And then we'll be taking, for each I, we'll be taking j that will run from I plus 1 to n minus 1. Why we are taking I plus 1? Why we are not taking I? Because if we just swap this element with this element, right? So if we swap 0 0 with 0 0, will it make sense? No, right? Because this is basically same element. That's where we are just avoiding this I. We are taking the element from the right. So when we are at 5, we'll be swapping only 6, and whatever remaining in the right, that will be doing. Now let's see how we can do that. So let's take an matrix. Let's say mat equals to uh, let's say 1 2 3 4, and then let's take 4 cross 4 matrix. then 5, 6, 7, 8. Then let's take 9, 10, 11, 12. Then let's take 13, 14, 16. Okay, right? Now let's take n equals to 4. That is 4 cross 4 matrix. Let's create a function called def, let's say, transpose matrix, and it will take, let's say, mat and size of the matrix. Then we'll be running a for loop for I in range. I'll be range from 0 to n, right? So we can avoid this. We can write directly this, and we'll take another for loop for j in range, and j will be range from I plus 1 to n. Now what we have to do, we have to swap these two elements. We have to this swap this mat I j, sorry, with mat j and I, and it will be equals to mat of ji and then mat of ij. Okay, so this is the operation. We are only we are only considering this upper triangular elements, right? Now let's transpose matrix, then it will take matrix, then n. Then at last let's create a function for print this matrix. So let's create a function to print the matrix. Let's say print mat. It will take matrix, and let's say size. Okay, let's avoid this. Now let's run a follow for row in mat, and then in each row let's consider them as elements in row. Then print yearly, comma, and end this with space, and after each row let's give a space, give a new line. Now let's call this print mat, then n. So what we are doing, first we are transposing the matrix, so we are modifying the actual matrix itself, then we are printing this matrix. So this is how we are doing. Now let's try to run this. Okay, I'm getting error, print mat. Okay, it will not take n. Now let's try to run this again. So you can see, so this is printing. Okay, first before doing this operation, let's print it out. Okay, now after this, let's put a print here. Let's put a print here also. Print. So why I am writing this print? Because of giving a space here. So if I run this, now you can see the actual matrix is 1 2 3 4 like this. And when we transpose this, so this row becomes column, this row becomes column, and this column becomes row. So that's how we find transpose of a matrix, right? We are not iterating over the whole matrix elements, and we are not considering the diagonal elements. We only perform the swap operation on upper triangular elements and lower triangular elements. So that's how we can find the transpose of a matrix, right? And what is the time complexity of this algorithm? So you can clearly see we are running two for loops, right? So this function, we are running two for loops. So one is from 0 to n, and another is from I plus 1 to n. So the time complexity for this algorithm will be around O of n square. Now let's look at our next problem. So the next problem is called rotate the matrix clockwise. Let's say you have given a matrix. Now, if you rotate this by 90 degree, we can see if you rotate this by 90 degree, this will look like this. Means this 1, 2, 3 will become like this, goes into the last position, 1, 2, 3. Then the 7, 4, 4, 1, it will be like here and like this. Now, how we can solve this problem? How we can rotate the matrix clockwise direction? So this is basically direct application of the previous problem, transpose of a matrix. Now let's see how we can do this using transpose concept. So this is the matrix. Now if we transpose this, so what will happen? The row become column and column become row. You can see this row, this 1, 2, 3 become column, and then 4, 5, 6 row becomes second column, then 7, 8, 9 row becomes the third column. Okay, right? Now if we take each row, let's take first row. So what are the elements? 1, 4 and 7, right? Now if we reverse the elements in this row at row 0, what it will look like? So the 7 will be swapped with 1, 7 will be swapped with 1, right? Then if there are another elements, that will also be swapped, means we have to reverse the element. Then it will look like 7, 4, 1. Then similarly for rows 2 or row 1, so this is basically row 0. Then for row 1, if we swap the elements, so what will happen? So this 8 will be swapped with 2, then this row will be reversed, right? Same for row 2, if we reverse the elements, so it will look like this. Now let's see what are the elements. So this is basically 7, 4, 1, 8, 5, 2, 9, 6, 3. This is also 7, 4, 1, 8, 5, 2, 9, 6, 3. You can see by applying two concepts. First, we have to transpose. We have to transpose the matrix. Then we have to reverse the row elements. Now, how we can reverse the row elements? Let's say, uh, so in the array, we have seen that. So let's say 1, 2, 3, 4, 5. Now, how to reverse this array? We have seen that if the length of this array is n, if the length of this array is n, we have to go up to n by 2. We have to go till n by 2. Then one by one, we have to swap the elements. And what are the conditions? The condition is ARR of I will be swapped with ARR of n minus 1 minus I. That we have to do. And what will be the range? Range will be from 0 to n divided by 2. So first we'll take the 0th element I equal to 0, then we'll be swapped this with n minus 1. Then we'll go to I equals to 1, then we'll swap these two elements, right? That's how we swapped. Now it is for 1D array, but for 2D array, how we can do? So basically we have to do the same thing. So in spite of this array, we have to take mat of I, then we'll be reversing this with j. We'll be taking another index j, and then we'll be swap with mat of I, then n minus 1 minus j. That will do. So this is the condition. So this array, we can consider this as this row. So this mat of I nothing but the row. So what are the steps? First, we have to make the transpose of this matrix. Then we have to reverse the row one by one. Then we can get the desired result. Let's see how we can solve this problem. So this was the previous problem. So here this matrix is given, size is given, n equals to 4, and we are just calculating the transpose of the matrix. Now let's create another function called def, and then let's name it rotate matrix. and it will take matrix, then n. Then what are the steps? First will be transpose this matrix. So will be calculate the transpose. It will take mat and then n, right? Then what is the next step? Will be creating a function called, let's say, uh, reverse row elements. Okay, now it will take mat n. So this is done. So this is basically two step. Now let's create this function. Let's make it def, and it will take mat in, right? Then we'll run a follow for I in range. Then I will be ranging from 0 to n. Then we'll be taking another follow for j in range, and j will be ranging from uh, 0 to n float divided by 2, right? Then we'll swap these two elements, mat of ij with mat of I in minus 1 minus j. So what are you gonna do? I'm gonna write mat of I and mat of j swap with mat of I, and then in minus 1 minus j, and then it equals to mat of I, mat of in minus 1 minus j with mat of I j. So remove this and let's call this function rotate matrix mat then n. Okay, so what we are doing, so first we are taking this matrix, this is a 4 cross 4 matrix. Then first we are printing this matrix to show the how the matrix is looking like. Then we are calling this function called rotate matrix. So how the rotate matrix operates, first it will transpose the matrix. Okay, it will transpose the matrix. Then what is the code for this transpose matrix? This is this. Okay, no, so we are just swapping the upper triangular elements with lower triangular elements. Then we're just calling this reverse row elements function. So what it will do, it will reverse each element in each row. That's why we're just running this nested for loops. Now let's try to run this. Let's first clear this out. Clear. And if we now run this, so you can see previously it was 1 2 3 4. This 1 2 3 4 is going at the end, and then this 13 9 5 1 that will move to here. So this matrix is basically rotated. So that's how we can rotate the matrix clockwise by 90-degree. I hope now you have understood these two problems, and hope you have enjoyed, and see you in the next lecture. Thank you.